Okay, friends, in this video, we're going to compare and contrast maximum versus a saddle. Okay, so here in this pan on the left, I'm going to enter the following. X cubed plus 1. And now look at this graph here very carefully. So if you're standing where my cursor is, and if you go to the right, then you see that the y coordinates are a little bit higher. You go to the left, you see that the y coordinates are a little bit lower. So how can we visualize it? Let me show you. You can just do, like, for example, 1, put that in there, you see, so that's the y coordinate with this point here is positive 1. And then you can do, okay, let me not do it there because I already have that there, but let me do like 1.01. So you see 1.01 is slightly high already, isn't it? And if you go to the left side, look very carefully, it might be like 0.99. And that's slightly lower if you look at it very carefully. Now here, maybe it helps if you zoom in a little bit, then you can study things a bit more closely. Look, right? Okay, let me zoom in a little bit more. Zooming is really good in math. It allows you to see things that otherwise are hard to see. You see, if you're standing here, and if you go to the right, then you see that the y coordinates immediately get bigger. You go to the left, you see the y coordinates immediately get lower. So when this occurs, you have both higher y coordinates and lower y coordinates, depending on which way you move. Okay, so we call this kind of thing a saddle. Now look at the graph on the right side. It's going to be qualitatively different. So I'm going to input, for example, negative x squared and then plus 1. Negative x squared plus 1. That's the graph. Okay, let's look at it. So first I'm just going to graph that line y equals 1 because it's the highest y coordinate on this graph. So let me do that now, okay? Y equals 1. And then for the sake of, okay, example, let's zoom in here because the goal is to just focus on specific locations. So let me zoom in even a little bit more here. And now what's different here is if you, beginning here where my cursor is, if you go to the right, immediately the y coordinates are lower. You go to the left, immediately the y coordinates are lower. Okay, so like you can represent that by, for example, doing 0.99. You see that? That's the red line. It doesn't matter. As soon as you deviate from here, lower and then lower on both sides. And the graph on the left side, if you go to the right, higher. If you go to the left, lower. So that's why the one on the right side is what we call a maximum. Again, this is, if you zoom in more, look, right? If you zoom in more, then you can really see this effect. And then in fact, you can take that red line, you can graph it at like 0.999 or something. You see this? And then you zoom in even more, and then it's very clear, right? If you deviate from this, where my cursor is, then it's lower. You deviate to the left side, it's lower. Here, it doesn't, with this one, again, right? It doesn't matter how you zoom in. Look at it very carefully. Look, this is 0.99, this is 1.01. You deviate, it gets immediately higher, it gets immediately lower. So that's the difference between a maximum, and the same logic would apply for a minimum versus something like this, like an x cubed curve. Leave a like if this has been insightful, helpful.